Hey there! Welcome back to episode 4. If you're following along, this is the third segment in episode 4. If you've missed previous segments or episodes, check the playlists on our channel. In this segment, we'll look at some core mechanics that make our game character come to life. The camera, the player input controls, and the state machine. These elements will work in harmony to create a movable game character in our 2D game world. Let's dive right in. The camera is a vital component in most games, even 2D games, providing players with a view of the game world as they move their characters around. In our game, the camera 2D node is a child of the player scene. This means it follows the player around, providing the perfect view of the action. This node works like our player's own personal photographer, capturing every moment of their adventure. We can adjust properties like Enabled to control whether the camera is active or not, giving us the option to use different cameras if we need to. We'll only use one in this game. We can tweak the zoom level to give the players a better view of the game world. Godot will display the camera outline in the editor if you set the Draw Screen property here. We can use the Transform Position property to position the camera relative to the player's sprite. This helps us keep the player in the right spot on the screen. Here, we'll see that they'll appear about 2/3 of the way down the screen with a Y position of -120 pixels. As the player moves around the game, they will always be in that spot on the screen. The level around them, including the world's tile map and parallax backgrounds, will automatically be framed by the camera. Perfect. Handling player input commands is key to creating responsive and enjoyable gameplay. We control our player's movement using a few physics parameters like speed, gravity, jump impulse, friction, and acceleration. These factors determine how the player moves and interacts with their environment. Because our player scene is based on the character body 2D object, we already have what we need here. The heart of moving the character lies in the move and slide function in Godot. This function automatically handles collisions and allows our player to move and slide along surfaces realistically. For our player to face the right direction, we adjust the X scale in code, depending on the player's movement direction. This simple trick, inverting the negative sign on the X parameter, gives the illusion that the player turning left or right. During certain animations, like the stagger animation when the player takes damage, we lock the player's input control. This allows us to control the game balance and prevents unintended actions during critical gameplay moments. For those who prefer using controllers or consoles, the Godot input system supports reading input directly from a variety of gamepads. We already talked about our DualShock PlayStation 4 controller input mappings way back in episode 1, but here they are again. Let's look at them in a little bit more detail. We identify the possible inputs by their friendly name, regardless of if they originated from a keyboard or a gamepad. And that way we can simplify the possible inputs the game needs to support. We'll look at the movement type inputs in a minute. First, we'll look at how the character can activate their offenses in the game. Projectiles add an exciting dimension to our game. The player doesn't start with a pistol, but they can find one in the demo level. We'll look at the item pickups, including the pistol, in episode 5. But let's assume the player has already found their weapon. This fire input is what the game uses when the player pushes the attack button. In our case, when that happens, we create bullets as instances of a bullet scene. This dynamic system allows us to control the behavior of bullets with precision. We'll set the bullet's collision mask to collide with tiles and enemies. We can place the new instance into the game exactly where the character is, and in the direction they are facing. By instantiating bullets as needed, and by limiting the number of bullets that can be active at any one time, we enable the player to engage enemies from a distance, while adding depth to combat and some basic strategy. As we get into episode 5, we'll explore more interactive elements like switches and toggles. These mechanisms enable players to manipulate the game world in a variety of ways, such as opening doors and revealing hidden passages. We'll use the Activate input for some of those mechanisms. Keep an eye out for that episode where we'll dive deeper into those level interaction mechanics. The Boost input key allows the player to move faster while running and jumping, but only if they have the Speed Boots item upgrade. Our state machine will automatically detect if the boost key is being pressed, and will give the player an increased velocity during movement, when we call the move and slide function. Speaking of the state machine, let's talk about the code that organizes the player's behaviors, the state machine. We store all the state-related code in our scripts folder. We'll go over those files in a second. The state machine is controlled by the custom transitioned signal. This signal is sent when the player's state changes and ensures smooth transitions between different player behaviors and animations. For debugging purposes, we display the current state name in the debug output window. This helps us keep track of what our state machine is up to behind the scenes. We'll use the movement inputs and the jump input to activate different states for the player. A state machine is a common software pattern that simplifies complex behaviors into manageable pieces or states. In most cases, only one state can be active at a time, making transitioning between states easy to handle. A game can have many different state machines for different purposes. We'll use one just to keep track of the actions that the player is taking and the animations that should be playing. Our player state machine only tracks the current movement state of the player, whether the player is standing still, running, jumping, or in a staggered state. The transition between those are handled smoothly by the state machine. By using just a few base classes, we can easily add more player states while keeping the code separate and simple. For instance, each state for our player coincides with one of the script class files here: idle, run, air, and stagger. The idle state is when the player is not moving, not pushing any input buttons, and is on the ground. When the player is pressing one of the movement inputs, and assuming they are on the ground, they will transition into the run state. If the player presses the jump input and they are not on the ground, they will be moved into the air state. The stagger state is activated when the player takes damage, and it locks the movement controls temporarily and applies a knockback effect to the player. We use a Godot timer node to set the invulnerability and input lock duration for this state. The stagger state itself only lasts a single game tick, but it applies a pulse to the player and bounces them back from whatever hit them. This knockback force is then interpolated over time using a tween object in Godot. And then, the player is immediately moved into the air state as they are pushed back and away from the collision. While the inputs are locked, the player cannot move the character, so they'll likely just fly back in an arc and land on the ground, while they'll move into the idle state while the timer continues to tick down. When the timer is finished, it sends this signal, and we re-enable the input controls for the player, allowing them to move out of the idle state once again. Our state machine allows us to manage each of these states' unique behaviors without clogging up a single monolithic movement function, and it keeps the code organized should we ever need or want to add more states to the machine. And that concludes part 3 of episode 4. We've covered some critical aspects of player interaction: the camera setup that keeps the player in the focus of the action, finely tuned player controls that allow responsive movement, combat, and collisions, and the intricate state machine that orchestrates the player's movement behavior. If you're finding this series valuable, don't forget to hit the like button and please subscribe to our channel. Before we get into the level scene in episode 5, we have one final video for episode 4 for the player scene. Check back soon for that segment where we'll talk about the concepts of lighting, shadows, and playing sounds in Godot. Thank you for joining us, and until next time, happy game developing.